Okay, here we go. Unit 6, Lesson 6. Hey, that's 6.6. Why is Jordan your featured athlete again? Because he went 6 for 6 in the NBA Finals. If you look at the clock in the background, it's pretty crazy. When he made his big shot over Byron Russell in the 1998 NBA Finals, I think it's the biggest shot in sports history. On the clock, it showed 6.6 seconds when it left his hands. Isn't that crazy? And he went 6 for 6 in the finals. I'm always looking for number patterns. It's kind of weird, math teacher. But anyway, here we go. Suppose a classmate missed the lessons on completing the square. This guy's the GOAT, by the way. And to find the center and radius of a circle, explain the process to them if it helps. Use a problem you've already done as an example. Okay, let's use this one. We have to do it for number 3 anyways. All right, so check it out. We got x squared plus y squared plus, that's some of the hardest part, come up with a creative problem, minus 10y plus 20 equals 0. Okay, first thing you do is you get this 20 over here. Right? Wait. Yeah, okay, so we're gonna do, next step is gonna be x squared, and then I'm gonna combine the x's, plus 4x plus something plus y squared minus 10y plus something equals negative 20. And you're gonna see why here in a second. Now, to figure out what goes into these boxes, you take the number that's in front of the x and you divide by 2, and then square that number. So 4 divided by 2 is what? 2. Square it, you go like this, plus 4. And then forget this is here. All right, now this one, divided by 2, 10 divided by 2 is what? 5, right? And then you square that, you throw that in here. Now, whatever, and then you cross that out. Now, whatever you do on this side, you have to do on this side. So plus 25 plus 4, and they're always going to be plus because you're squaring them. So now you have x squared plus 4x plus 4 plus y squared minus 10y plus 25 equals whatever these are. Negative 20 plus 25 is 5, plus 4 is 9. All right. Then you change this to a squared binomial, and you change this to a squared binomial, and you change this to r squared. So we're trying to go like x. In this one, it's going to be plus h squared. And this one is going to be y minus k squared equals r squared. So this one goes to x plus 2 squared. This one goes to y minus 5 squared. 9 is the same as 3 squared. Your center is negative 2, 5. And your radius is 3. Yeehaw. Okay, number 2, match each expression with the value needed in the box in order for the expression to be a perfect square trinomial. That's why I'm using this box method, because it comes up more. But all you got to do, remember, divide by 2, whatever that is, square that. So 8 divided by 2, 8 divided by 2 is 4. What's 4 times 4? 16. All right, what's 20 divided by 2? 20 divided by 2 is 10. If you want to write it, you can. 20 divided by 2 is 10. What's 10 times 10? 100. This is 100. All right, what about 16 divided by 2? 16 divided by 2 is 8. 8 times 8 is 64. So this one should be 64. And then this one is 9 divided by 2 is 4.5. 4.5 times 4.5 is 20.25. So in other words, boom, 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 or A, D, gosh, these are hard, B, C. All right, find the center and radius of the circle represented by this equation. Let's act like we haven't done it. All right, x squared plus y squared plus 4x minus 10y equals negative 20. Put the x's together. X squared plus 4x plus your box plus y squared minus 10y plus your box equals negative 20 plus your box plus your box. We just did this problem, FYI. 4 divided by 2 is 2. 2 times 2 is 4. Cross that out. 10 divided by 2 is 5. 5 times 5 is 25. Put the boxes over here. 4, 25. Here we go. X plus 2 squared plus y minus 5 squared equals 9. Center, negative 2, 5. Radius. This is hard, actually. Some people say 9. It's actually 3. Hey, same as up here. All right, so that's the box method for completing the square. All right, number 4, here we go. Select all the expressions that can be factored into a squared binomial. This just comes from experience and practice. So this one will be y plus 1 squared. This one works. This one, let's see. This one would work. This is going to be w plus 5 over 2 squared. How do I know? Because 5 over 2 squared is 25/4. Okay, this one's going to be nothing because it would have to be 25 right here. This one is good. This is going to be x minus 5 squared. This one's good because 10 over 2 is 5. 5 times 5 is 25. This one's going to be x plus 5 squared. And then this one, 20 over 2 is 10. This needed to be 100, not 40. Okay. An equation of a circle is given by x plus 3 squared plus y minus 9 squared equals 5 squared. Apply the distributive property to the squared binomials and rearrange the equation so that one side is 0. Okay. So let's apply the distributive property. We're going to have x squared plus 6x plus 9, which I just used FOIL in my head real quick. Same thing as x plus 3 times x plus 3. X squared plus 3x plus 3x plus 9. Okay. Plus, I'll go a little slower, sorry. Y minus 9, y minus 9. That's going to be the same thing as y squared first. Outsides are y and negative 9. That's going to be negative 9y. Insides are negative 9y, so that's minus 18y. Negative 9 times negative 9 is plus 81. And then don't forget we have a 25 over here. All right, so we're here now. So rearrange and then apply and then rearrange so one side is 0. So here we go. we're gonna get x squared plus 6x plus 9 plus y squared minus 18y plus 81. To get one side to be 0, just subtract 25 to both sides. Minus 25 equals 0. Now you got to combine all the like terms. So we're going to have x squared plus y squared. These are the, well, I guess, plus 6x minus 18y. Now this is hard. 9 plus 81 is 90. Minus 25 is 65. Equals 0. That'll work. Remember, addition is communicative. So if you wrote these in a different order, that's okay. But there you go. Number 5. All right, number 6. Graph the circle. X plus 1 squared plus y minus 3 squared equals 16. So I automatically know the center is negative 1, 3. Radius is 4. That's it. Negative 1, 3. Radius is 4. 1, 2, 3, 4. Now I just get my compass out. Here's your center. Negative 1, 3. I love about these compasses, you can adjust them even when they're super tight. All right, here we go. Wow, that's not the greatest. Make sure it actually goes through the perfect point. A little bit bigger. Right there. Now I'm going to tighten it real tight. Okay, here we go. Here's our graph. Now if you want to label this, center, negative 1, 3. And then you could label your radius. Radius equals 4. That'll work. Now find the distance from the center of the circle to each point on the list. So we got to go from the center to 2, 1, right there. There's 2, 1. Okay. How do you get that? I don't know. You just run Pythagorean. Super easy. You got 2 and 3. So you got 2 and 3. So for this one, to get this point right here, this is going to be C, right? For the distance to this point, that's going to be represented by C. And to do that, you just run a squared plus b squared equals c squared. So 2 squared plus 3 squared equals c squared. So 4 plus 9 equals c squared. C equals radical 13. Second, x squared 13. 3.6. Ooh, barely snuck it in there. 3.6. All right, 4, 1. This is gonna get sloppy. I hate it when they do this. Oh well, we'll find a way. Okay, what's the distance from the center to 4, 1? This is another easy one. Show you why. Claire's over here with crayons. What's up, Claire? Don't say hi to the camera. Don't worry about it. Anyway, she's here drawing. But anyway. Here we go. We're gonna get the distance from here to here, which is represented by a squared, 2, 1, 2, 3, 4, 5, plus b squared 5. So you just go 2 squared plus 5 squared equals c squared. 4 plus 25 equals c squared. 29 equals c squared. C equals the square root of 29. Claire, stop bugging me. Thanks. 5.4. So 5.4 on that one. Okay, last but not least, 3, 3. 3, 3 looks like it's on the circle. We'll find out. This one's really easy. 1, 2, 3, 4. Okay. What do these distances tell you about whether each point is inside, on, or outside? This one's on. 4, 1 is outside. And 2, 1 is inside. And how can you tell? 3.6 is less than 4, so it's inside. 5.4 is greater than 4, so it's outside. 4 is the same as 4, so it's on. So if the distance ends up being 4, that 5's for the pink triangle. But if the distance ends up being 4, so if the distance ends up being 4, you know this point is on the circle. This point looks to be on the circle, so the distance is going to be 4. You can probably prove that real quick. Let's see. 1, 2, 3, 4, and 1. No, that one's going to be off, I think. Anyway. If it's the radius, it's on. All right, so let's create a math answer for that. So if distance equals radius on, if distance is greater than radius outside, I'm gonna end with a bang. If distance is less than radius inside. It's that simple. All right, cool. Number 7. The triangle whose vertices are 3, -1, 2, 4, and 5, 1, transformed by this rule, x, y to 2x, 5y. The image is neither similar nor congruent because the coefficient in front of the x does not match the one for y. A cube has side lengths 3 inches. So I'll just draw a cube real quick. My daughter really wants to set up cornhole right now. She got as a birthday gift. But anyway, 3 by 3 by 3. Okay, so you got a cube. It's a cool skateboarding movie called Gleaming the Cube. Anyways, it's neither here nor there. But anyway, you got a cube, side length 3. Side length 3. Alright. Sphere has a radius of 3 inches. Oh my. Okay, here we go. So sphere. So I'll draw these to scale, obviously. Alright, so we got a cube and a sphere. Okay, now the radius is 3 inches. R equals 3 inches. These are in inches. Okay, before doing any calculations, predict which solid has greater surface area to volume. I'm going to say the cube. Why? Because the sphere always minimizes surface area. Calculate the surface area, volume, and surface area to volume ratio for each solid. Hey Claire, I need a favor. Go ask Alexa, because I forgot off the top of my head, what is the surface area formula for a sphere? See if you can get it. This will be a good learning moment for students. So Claire, go run down to Alexa. Here, I'm gonna give you this. Here it is. Say, hey Alexa, what's the surface area formula for a sphere? And then write it right here and bring it back.
Okay.
All right, thanks. Okay, now surface area.
Wait, so I asked, what is the surface area formula of a sphere?
Yep, surface area formula of a sphere.
Okay.
All right, thanks. Okay, so let's look at this area right here, just of one face. It's gonna be 9, right? 3 times 3, and there's 6 of them. So let's go cube. Surface area is 9 times 6, which is 54 square inches. Let's see, volume of the cube will be 3 times 3 times 3, which is 27 cubic inches. Surface area to volume ratio will be 54 over 27, which equals 54 divided by 27, which is 2. Oh yeah, 2, duh. So surface area to volume is 2. Now let's look at the sphere. Claire's gonna be back any second. Surface area, gosh, that's like 2 pi r something. Volume is 4/3 pi r cubed. This is the only one I don't remember. Whoops. Which equals 4/3 pi times 3 cubed, which equals 4/3 pi times 27. So that will equal, just do parentheses if you can, or actually do this, 27 pi. That's this times 4 divided by 3. Did you get it? 113.09. You got it?
It's equal to 4 pi times the radius squared.
Awesome. So surface, there's Claire's work. Surface area formula is 4 pi radius squared. Whoops, that was off. So 4 pi radius squared, we'll just do this over here, is the same thing as 4 pi times 3 squared. That's going to be 3 times 3 is 9 times 4 is 36 times pi is 36. Didn't even lose any time. That's awesome. Oh man, 113.09. Crazy. Wait a second. Surface area and volume is the same? Oh my. Okay. Why does that seem wrong? Anyway, surface area and volume is the same? Huh. I'm a little weirded out by that. But anyway, that would be 1/1. So surface area to volume will just be 113.09 divided by 113.09, which is the same as 1. So we were right. The cube has the greater surface area to volume ratio. My goodness. What a problem. Even an assist from a 9-year-old. All right, adios. Go MJ. He's the GOAT.